This is my Casio FX9000P, which used to have a broken display, but now, as you can see, it's actually working. So originally I had this in there, which is just a Raspberry Pi Pico with some connectors here to GPIOs, and I had that hanging out of the side of the case here. In fact, I had two of them because two RAM chips were broken. And now what I've got is a couple of these in there, which is a PCB I made up, which has got an RP2040 on it, and it's got the footprint of a RAM chip. It looks like a RAM chip, so it'll plug straight in the socket, and there's two down here, and they're currently running 2 bits of the display. This is a 4K by 8 block of RAM here. Each chip is 1 bit of that times 8, and 2 of them were broken, so they're replaced here and they're working fine. Now, I had 2 goes at this. This is an earlier PCB that I did, same circuit actually, but unfortunately the layout wasn't very good. I didn't have very good grounds on there, and I also had trouble soldering the RP2040 onto the PCB. So these boards, I made up about 3, I think, and none of them would even program. So it wasn't possible to get the program onto the external flash chip. It just didn't work. Now, I'm pretty sure that the layout was a bit rubbish, so this one's got much better ground plane and the power plane in there. It's a 4-layer board. And the other problem I had was that the soldering of the RP2040 on these blue ones, I really had a lot of trouble. I've had a lot of trouble in the past soldering the RP2040. It's a really horrible package, really, to try and get on the board manually. So I tried manually soldering it. I tried cutting a stencil and using solder paste, cutting my own stencil using a vinyl cutter, which really can't handle the pads. These are really small pads. It's 0.5 mm pitch, and they're probably about 1 mm long, so very small for a vinyl cutter. So what I did was, with these boards, the purple ones, version 2, I actually bought a stencil from JLC PCB, stainless steel stencil, which arrived. I tried that, but the problem with that, I think, was that it was just applying far too much solder. So the solder, once you put the IC on, would sort of squish together, and all the pads, the solder, I think, runs together, probably under the IC, because I couldn't see any shorts outside. If there were any, I took them off manually, and it still didn't work. So I think it was applying too much solder. So then I tried manually applying some solder. I think that worked better, but they still didn't work. Then I tried hand soldering by basically running the iron along the very small amount of pad that you've got left on the outside of the IC. I think you can just about do that with these ICs. It's I think it's is it a QFN or a UFN? It's the sort of flat package with pins that are just on the underside of the IC, basically, with a little tiny bit on the side that you can maybe get to. But anyway, I failed to make 2 of these, but then I sort of had an idea and found a method of soldering these RP2040s, which so far, and I've made 4 of these PCBs, 3 of them worked first time, and 1 of them didn't work because the IC was misaligned by 1 pin in one direction, which was just a sort of surface tension soldering problem in the oven. So I took that IC off and realigned the IC, put it back on, and that is fine. So I've made 4 of these. 3 of them were soldered first time, the 4th one had an obvious fault. Now the problem with the RP2040 is if there's some problem with the soldering, it's usually under the chip and there's no way of getting to it, so you have to take it off and have another go. So the way that I solder these, which was so successful, was to basically take the footprint on the PCB of the RP2040, put quite a lot of flux on there, and tin the pads. So I'm using the pads themselves really as a stencil to apply the solder, and it's a very small amount of solder. Then, making sure there's flux there, I hold the IC on with the flux, and then put it in the oven and reflow it, and that has worked perfectly. There's been a couple of pins maybe that have got some solder blobs on the outside, but I took those off because as the IC pulls down with the surface tension when the solder melts, you tend to find the solder comes out. But that has worked really well, so I'm much happier soldering those now. So I've got 2 PCBs in the FX9000, 2 more here. All 4 of those work. I haven't made any more. I might make a couple more. I think I've got 6 PCBs, so I might make a couple more because I'm fully expecting more of these IC RAM chips here to break. They're MT chips, and apparently they're quite unreliable. So I haven't got enough to do the entire block of RAM, but I will. I've got 6. So if another couple fail, I've got the 2 here made already. But as you can see, it's all working fine over here. Display fine, haven't really had any trouble with it since I put those PCBs in. The PCBs don't have any level shifters, and the Pico version, that also doesn't have any level shifters. These PCBs have been running for hours now. When I come into the workshop, I turn the machine on and run a test program, and they're fine. So I think they are 5V tolerant, the Pico, the RP2040. We'll see with this PCB here. I mean, maybe that makes a difference having a bare 2040 on there with regard to 5V tolerance. I don't think it will. I can't see how it can really.